Find the derivative of f of t equals 2t to the fourth minus 3 quantity times t to the fifth plus 4t quantity. Then evaluate f prime of 0. F of t here is made up of the product of two functions, 2t to the fourth minus 3 times t to the fifth plus 4t. One option is to use the product rule. Another option is to take the product directly if possible, which will make the derivative process a little simpler. And we can take the product directly by FOILing this out. So let's FOIL this out. First, 2t to the fourth times t to the fifth will be 2t to the 4 plus 5, 9. Outside, 2t to the fourth times a positive 4t, 2 times 4 is an 8, so we will end up with a positive 8. T to the fourth times t to the first, you add the exponents 4 plus 1, t to the 5. Inside, negative 3 times t to the fifth. And then last, negative 3 times a positive 4t, which will be a negative 12t. It looks like we can combine together the second and third terms. So we will have 2t to the ninth plus 8 minus 3, which is plus 5, t to the fifth, and then minus 12t. We can now take the derivatives of each of these terms separately, since they are combined by addition and subtraction. F prime of t equals to, the first term is a power rule. Bring the 9 down, multiply it with the 2, 18 t to the 9 minus 1, which is 8. The next term, also a power rule. Bring the 5 down times the 5, 25 t to the 5 minus 1, which is 4. And then the third term is a constant times t, a negative 12 times t. The derivative is just a constant, negative 12. So there's our f prime of t. The other thing to do here is evaluate f prime of 0, which means to plug a 0 in for each of the t's in f prime of t. 18 times 0 to the 8 plus 25 times 0 to the fourth minus 12. 0 raised to any power is still a 0. 18 times 0 plus 25 times 0 minus 12. 0 times any number is 0, so we have 0 plus 0 minus 12. 0 plus 0 minus 12 will give us a total of negative 12.